Here's our last example on financial money interest stuff. Suppose you invest your first annual bonus of $4,000 in a retirement account, which promises a minimum of 5% interest compounded continuously. How long will it take for this investment to triple in value? So we're using our new formula, A equals PE to the RT power. Since we're tripling the value, that would mean taking our 4,000 and tripling that to 12,000. Again, the actual amounts don't matter as long as we understand that the ratio of the initial amount to the final amount is 3 because it's tripled. But I'm going to go through that whole process anyway. I meant to write in our other numbers here, which was mostly just the rate, 0.05, and then that times t, and we're trying to find t, and so that's our variable. Okay, we're going to go ahead and divide both sides by 4,000 so that we can isolate our exponential. Again, as predicted, 12,000 divided by 4,000 is a lovely 3, which is what happens if you're going to triple something, just like we got a 2 when we were doubling it. So now that 4,000 has been divided, we no longer have a coefficient on e, which is important because we want our exponential to be isolated. Okay, so next we are going to take the natural log of both sides. Make sure you do natural log because you have e in the problem, so doing natural log simplifies it immensely. So now that we have natural log of both sides, we're going to go ahead and use our power property, which means we have the coefficient 0.05t instead of exponent. Now here is where the magic happens because natural log e equals 1. And 0.05t times 1 is just 0.05t. So we're left with a beautiful little result. Natural log 3 over 0.05. No natural log needed on there because the natural log part of this thing canceled out with the e. So this is going to give us the result when we put it in the calculator. The nice thing about this is you can really just replace the 3 with any value that you're trying to get to. So if you're trying to double it to 8,000, that would be a 2. Or if you wanted to do 150% of it, that would be to like 6,000, then that would be a 1.5. So that number there is just the ratio of the initial amount divided into the final amount that you want. Okay, so using my calculator, I get natural log 3. Make sure you close the parenthesis if there is one there that you need to close before you divide by the 0.05. This gave me 21.97, so approximately 22 years to triple that money in value. So I just am finishing up my 22nd year of teaching. The more money I could have invested 22 years ago, the more money I would have now in my retirement accounts. So the best time to start saving for retirement is today, as soon as you can. You can't go back in time, so you just start when you can. You don't say, hey, I'm going to do that next week when I get that bonus or whatever. You just start putting a little bit away now, and then before you know it, you'll be older and wish you had done that, and you'll have it if you did it.